Je cherche trop, je cherche trop. Je cherche, je trouve.
Machine learning and data.
When we talk about artificial intelligence today, we most often hear machine learning. There are two ways to learn. The one that comes from the knowledge that is passed on to us is the symbolic approach, and the one that comes from experience that we acquire is the digital approach. Machine learning is based on the digital approach, i.e., experience. The principle is not telling the computer exactly what to do. No, we'll program it to learn from examples, based on statistical approaches.
Learning to learn.
I'll use the example of David Lauper, researcher and science popularizer, to explain. Let's say you are a botanist. You are walking in the forest, you make some observations, you measure the height and diameter of the trees, and record it all in a data table. Once you get home, you draw a graph with the diameter on the x-axis and the height on the y-axis and place your data on it. You quickly realize that the two are linked and that by drawing, in this case, a straight line through the points, this will allow you to predict the height of a tree from its diameter.
Machine learning works the same way. You provide the calculation with input data and output data. You train it to find the relationship between the two, the straight line, by adjusting the parameters of the calculation. This is what we call generalization. Once this learning phase is done, we can make predictions. That means producing a correct answer for similar data that the program wasn't trained on.
That's what machine learning is all about, to be able to make predictions.
Predictions that are not necessarily predictable.
How do these machines learn?
In fact, there are several learning techniques.
We'll just talk about the two main ones. Supervised learning is the example of the botanist that we just saw. First, there is a training phase where the data labelled by humans feed the algorithm. That's why it's called supervised. Then there's a prediction phase where the algorithm will give an answer for data that it has never seen. This is used to extrapolate value, but it's also used to differentiate cats from dogs, for example. Then there is reinforcement learning, where the algorithm learns by being immersed in an environment and where it will adjust its parameters depending on the positive or negative reaction that follows each of its actions. A bit like a child learning to ride a bike who falls and gets up again. This algorithm is mainly used for robots or autonomous agents and also works very well in virtual worlds or in specific situations.
Perfect for the game of Go, but not so good for autonomous driving. Imagine if a car had to crash thousands of times before a machine learns to drive it. Every app has its own algorithm.
I've heard of deep learning. What is it exactly?
Neural networks.
Deep learning is a machine learning method which is based on artificial neural networks.
Artificial neural networks offer a calculation method which is inspired by the brain. Biological neurons are cells connected to each other. Simply put, when a neuron receives a signal, it can either send nothing or send its own signal. Artificial neurons are mathematical constructs that roughly mimic how real neurons work. Each neuron combines its inputs and provides an output. To make complicated functions, you can combine many neurons. That's what we call an artificial neural network.
This method is not new. In fact, it dates back to the 1950s, but it requires considerable computing power and data. In the mid-2000s, with the increase in processor capacity and the massive data made available by the internet, everything changed, and we could move to the deep phase.
The neurons are arranged in successive layers. The results of the first layer of neurons will be used as an input to the calculations of the others, and so on. The more layers there are, the deeper the network. That's why learning by deep neural networks is called deep learning. Let's take an example on image recognition. How is the neural network able to learn on its own how to recognize a picture of a cat when all it sees are pixels? From the thousands of cat photos that it was exposed to labelled as a cat, it will be able to adjust the parameters of its calculation to extract characteristics that determine what a cat is. Once the program has acquired the notion of what a cat is, it can make a prediction on a new image.
Sure, at the beginning, the network will get a lot wrong, lots of mistakes, but the model will be built by adjustment, by little successive changes. By comparing these results and adjusting its calculation, it can identify a cat in a picture that it's never seen before.
Exactly. It's about statistics. As Mark Schoener explains, research director at INRIA, it's not about programming one thing to get an exact result, but rather to find patterns, even if inaccurate, from data.
Hence the importance of data. You can have the best algorithm in the world, but if the data is bad or poorly classified, the results will be bad too.
The data challenge.
For example, if we train an algorithm to recognize a sheep in a picture, by showing it white sheep, it won't be able to recognize black sheep. The data must be varied and sufficiently numerous. Without this, generalization is not possible.
You also need well-classified data to properly train AI to recognize sheep in a picture. Not only do you need many sheep pictures, but they also have to be well annotated. In other words, in this case, the sheep is framed, and that it is specified that the frame corresponds to a sheep. As we have seen, this involves thousands of images which must be annotated by hand so that the AI can learn correctly and then make good predictions afterwards from images that are no longer annotated. A long and arduous task, but also very important because bad annotations lead to bad predictions.
Sometimes we annotate data without even knowing it. You know, like some captures, where you have to find the boxes that have cars in them. You are annotating an image or checking that it has been properly annotated, and not necessarily proving that you are a human being.
What's more, there is a great deal of invisible work done by humans who are paid a few euros per day to click on hundreds of images. Have you heard about Amazon's Mechanical Turk?
Yes, I went to the site. Indeed, the rates are ridiculous.
The click workers. Where does the data come from?
Data can be collected automatically via sensors such as telescopes, surveillance cameras, microphones, and sensors measuring air quality. They can also be produced by users, in particular via the queries submitted to a search engine, publications, comments on social networks, connected objects, and purchases made on a credit card. It is an exchange of free services between the big groups and us.
That's it. When it's free, you are the product.
Yes, it's true. The big American or Chinese private groups have large amounts of data on tap, which raises problems related to independence. Today in China, a social node system has been set up to evaluate citizens' behaviour. Data is mainly collected via surveillance cameras, social networks, and an AI assigns a score that allows or not to access public services. This massive data is boosting startups at the same time, because whoever has the data has the power to run the models and improve them. Hence the importance of the GDPR to regulate all these practices, so that the European states and their citizens have a little more control over their personal data.
Big data consumes a lot, doesn't it?
Data is stored in big centres. The cloud is not an actual cloud, it's pizza boxes. Entire server towers that heat up and need to be cooled with air conditioning. Algorithms, when they are at AI level, need exceptional computing capacity, which means supercomputers which bring together several dozen or thousands of processors in huge buildings. Yes, it consumes a lot, and it's a risk for the whole system. It is up to us to be vigilant about the cost-effectiveness of artificial intelligence. It can be a great tool, which provide a lot of services, but also there are also apps that push us to consume or track us. Like any technology, it depends on how it is used. It's up to us to make sense of it.